Hello, welcome back to More Fun Fixing It. The other night I was doing a live stream, and at the end of the live stream I said it was a charity live stream and we sold something amazing and raised loads of money, which was great. But don't let that put you off of this video. At the end of that video I decided to repair something, and I gave the viewers the choice of a ZX Spectrum or a Commodore 64, put it to a poll, and they chose a C64. I'd started pulling out C64s from the various places where I've got broken C64s all around me, and none of them were quite suitable. One of them you'll see in a future episode, which was it was completely full of dust bunnies, and there was some corrosion in an unusual place. That was a C64C. It was this one here. I'll give you a quick sneak peek. Look. So I'm not going to show you any further than that, but you can see all of the stuff that's going on in there. That looks quite interesting. I pulled out this one, which says nice power, black screen. So this means that the case is nice, that the LED is lighting up, but there's a black screen when plugged in to a display. And there's no surprise because there's no SID and there's no PLA. Now, I thought that meant I'd been in here already, maybe diagnosed, say, a bad PLA and the SID was bad, and put it to one side to repair later. But I didn't make any notes, and on my repair tracking software, I didn't have any notes on there either, so I hadn't done anything to it, and I didn't realise this until after the stream. So I quickly plugged it in, and something became apparent. But I'm going to go through the repair diagnostic steps that I went through earlier with you now, so that you can see how I arrived at this conclusion. So I'm just going to plug in the display and some power, and I need a PLA, which is here. This is a working PLA, and that should now make sure the socketed chips, nothing else is socketed apart from these four over here, and obviously the SID and the PLA, and then we're going to switch it on. Just a black screen. Okay, so with that, the next thing I usually do is plug in a diagnostic cartridge of some description. Now I've got my new DesTest Switch Select here. I've got my normal diagnostic cartridge, which has DesTest Max and DedTest and normal diagnostics. And I have the C64 Analyzer V2. I also have, this is a DesTest Switch cartridge. So combining all of these, I usually get some kind of output from a machine. So yeah, let's put in this one, and I've got so Matt, I've got a little bit of feedback for you. When you've plugged the cartridge in here, you can't see the bottom row. So I'm always thinking, what is that down there? I know it is the one that I want bank 1 and then the third one. So this is now on the right one, but I can't show that. So can we move the sticker up so that I can see Dead plus Diagnostics, factor of Matt 26. This is Matt Desmond's amazing creation. Right, so that one gives us a black screen. So we've got DesTest Max Switch. If I change it to bank 0. And that gives us a black screen. So we're getting an LED, which is nice. I'm going to try this one. And that's given us a black screen. So we'll go back to the old traditional cartridge and start with DedTest. No, DedTest I think is on that one. Absolutely nothing, just a black screen. That should be DesTest Max, black screen. We'll go to Diagnostics, but if DedTest can't display anything, then Diagnostics is not going to display anything, and that's not working. So not any of those three cartridges, not one of them do anything. Now this one, bearing in mind that the PLA is known good, if I turn this one on, and I'm going to zoom down a bit so you can see the display. There we go. And the C64 Analyzer, if I hit system check, it'll run through its checks. Reset is okay. CPU 8701 is the timing chip, is okay. VIC is okay. CPU is okay. And the PLA is going to come up bad. ROM 8000 kernel. Now, someone commented on one of my previous videos saying that this always, and to be fair, I haven't updated this again, and it has got some new useful updates, which I might do later in this video, but I might not. Someone commented that it always shows that the PLA is bad, whatever happens. It's not true. The PLA being bad, you know, it can be triggered by all sorts of things on this board. What that is telling me, though, is that the CPU and the VIC2 and the timing is good and the reset is good. So I don't need to worry about those. So I've got clock and I've got reset. I don't need to get the oscilloscope out now to check those. So where do I go from here? Normally you would start poking around with an oscilloscope, but my next thing is to actually grab a thermal camera and point this at it. And straight away, the machine's not even on. And there's a chip over here that's lit up like a Christmas tree. And if I turn the computer on, that is going up 37, 40, 45, 49, 50, 55, 58, 66, 68, 69. It's going up. Oh dear, it's going to go into meltdown. And it's this chip here, U25, which is a 74 LS257 logic chip, one of the multiplexers for the DRAM. Now this one, like I say, is lit up like a Christmas tree. I have got another thermal camera here I can show you with. Look at that. That is a poorly chip. I'm not touching that one. That would definitely burn your hand. Hello. Whether you're designing your own test carts, creating a fresh replacement motherboard for a vintage system, or putting together a completely custom retro build, PCBWay is the go-to service. They offer incredibly precise custom printed circuit boards with rapid turnaround times, making prototyping an absolute breeze. And they don't just do PCBs, they also offer CNC machining, sheet metal fabrication, and advanced 3D printing services, which is perfect for fabricating those impossible to find replacement case parts or custom brackets. Their online quoting system is seamless and the manufacturing quality is always exceptional. Head to the link in the description to get a discount on your first order with PCBWay, and a huge thanks to them for supporting the channel. Cheers! All right, carry on. So at this point, I've already pulled a 74 LS257 that tests good out of my stocks. It's got slightly manky legs on it. I need to give those a bit of a crush and make them a bit straighter. There's quite a lot of solder on those. And I will heat up my desoldering station, pop this chip out and see if that is actually indeed the cause. I think if I left it switched on long enough and upside down, it'll probably desolder itself. It was getting that hot. Now I know not everyone's got a thermal camera, but you can use the finger test. In this case, you'd have burnt yourself. 100 degrees. I measured this chip at 100 degrees off camera, and that is going to give you a blister. But the other thing you can do as well is get a can, get some isopropyl alcohol, spray that on there, and look for the one that evaporates fastest. It's not quite as obvious which one. Sometimes, you know, with a thermal camera, you can tell that, say, a bank of identical chips, if all of the DRAM are the same, and one of them is maybe stone cold, or just a few degrees cooler or hotter than the others, that can give you a clue. But for obvious stuff like this, you don't need a thermal camera. I would have found it without a thermal camera just by scalding my finger. And I've done that before. Okay, this one's coming out Yep, not going to need any extra heat on this. Is the worst chip tester in the world. I'll test the chip that's going back in there first. Let's turn it on so it can do its self-test. And that comes up as a 75 LS 157 or 257. It tests them both the same, but it is a 257. And this is the MOS equivalent, which is a 7708. But that is a 74 LS 257 on the schematic. If I press that now, not found. Dead chip, no surprise because it is completely shorted. Cheap and nasty desoldering braid. But it's not actually nasty. I just got this off of AliExpress just for mop-up jobs like this. It works fine. I don't need to use my fancy MG Chemicals stuff. Socket, pink tack. Some of these capacitors have been properly crushed. It's possible to get shorted doing that. So as this video goes out, I shall be in Swindon at Retrofest 2026. If you fancy coming along, I think there's still tickets available for Sunday as of recording this. And I think that they are selling fast, so there might not be any available. But yeah, come along if you can. And hopefully we're going to have a really happy, relaxed, chilled vintage tech weekend with all our friends. It's going to be great. We're going to have so much fun. Right, let's put the new one in. I say new. Right. Now the question is that the only problem? Because it could have taken other things with it. So this could turn into a long repair, or this could be the end of the video. It's probably the end of the video. But we will do our due diligence and test everything. I will connect up the test harness. Now there's no SID in here, so I will have to add a SID in later. In fact, let's get a SID in there. There's a test SID. But I'll have to build up a SID kick Pico for this. I've got a few of those that I need to build up for other machines as well. Always like to spray the connectors on these because it will give the edge connectors a nice clean as I put this on. The only one I didn't do is this one. Right, now I'm going to put in the switch select cartridge. I'm going to put it on dead plus diag factor of Mach 26. And that should run through dead test, which is a bit unnecessary. I don't really need that. And then the normal diagnostics all in one go. Hello. All right, so we're not done. What's going on there? Oh, one thing I haven't cleaned is the cartridge port. Oh, a pink screen. What's going on? Let's go back to this one. Oh, that's working. All right, I might have to pass on some feedback to Matt Desmond about this one. Maybe just the action of plugging an extra cartridge in. Oh, we've got some bad memory. So everything else is passing. Except U12 and then 21 to 24. So U12 is that one. And then 21 to 24 are these, this row down here. So maybe, or this row down here being connected to this one, and U12 being closest to this one. It could be that multiplexer is gone as well. So this is not the end of the video. Things just got interesting. Right, I do want this, that has crashed as well. I do want this verified. In fact, let's try this DesTest switch cartridge. It doesn't like that either. Yeah, that's, I think all of that memory is playing havoc with that one. Okay, this one works independently, so this should give us a slightly different picture than the other cartridges. All right, so if I hit system check, again, reset is okay, time is okay, VIC is okay, CPU okay. I reckon it'll come up PLA bad again. It has, but the PLA is not bad. I'm not sure what to do first. It could just be this other MOS chip, this other multiplexer, that's causing problems still. But with all of this being bad down here, and only one of these up here, I'm not sure. I'm a bit perplexed why the DesTest cartridges are not able to run. I'm going to put this on. Is this no RAM check? No, no RAM check. So it will run through all the rest of the checks. Everything else is passing. Looks like, I can't hear it, but it looks like the SID is making a noise. The CIAs are counting nicely. So, and the ROMs are, the checksums on the ROMs are showing up. So that was one thing I was wondering, whether maybe one of the ROMs has actually gone bad. Ah, okay. Right, okay. So that other MOS 74 LS257 is now at 50 degrees. The memory all looks reasonably similar to what it should be, you know, to the other memory. But that's, yeah, that's up at 50 degrees and climbing. Everything else looks really good. Ooh, that SID is at 60. So I reckon both of those 257s have popped, which makes sense. They would have been from the same batch, and for them to expire at around the same rate makes sense to me. Right, let's get that other one out. But at least it turned into a more interesting video than just one dead chip. And I've heard plenty of people say that when they repair a C64, if they come across any MOS chips, any MOS logic chips especially, they will just replace them even if they're working. Now, if this was my machine and I was going to be using this every day as my daily driver C64, then I would do the same. But these are working, or they're often working chips anyway, and these are not my computers. It's not my money to spend, so I'm not replacing all of the chips. I don't think it's necessary to replace a working chip that could last another decade, 2 decades. You don't know. There's just no way of knowing. It's just because they're MOS chips doesn't mean they're all going to break. Plus, I've had NT RAM chips that seem to be working fine. They're meant to be another thing that you're supposed to change as a matter of course, but I don't think that that's always the case. Otherwise, we'd end up with no original chips in any machines. Give them a wiggle. Seems to be a decent board to work on. Don't think it's going to cause me any issues. I hope not. Yeah, it's just coming straight out. Not had to heat these ones from above. with hot air, which is nice. There's a leg hanging on there. The legs are all over the place on these. Lots of hooks. Okay, let's try it in the worst chip tester ever. Not found. Dead. I need to find another one of those now. 257. God, it's got even shorter legs. All right, found this 257, which is good. I found this one, which has got some hilariously curled legs. This one must have been hanging on for dear life to whatever board it was removed from. This is my backup in case the other one has legs that are too short. Yeah, that one works as well. I did find this 7708, which is the same as the ones that have been taken out, 7708s, which is another Moss, and it's got a little tick on it. And when I test this one, it comes up as not found. And I'm wondering if that is actually going to... I'm going to try that. I'm going to try that in the board and see if it works, and whether this can't tell the difference between a Moss... Well, it can't test a Moss chip, which might mean that the one that I took out is working. So let's get a socket in there. Okay, we'll try the short-legged chip first. This is definitely a working LS257. Oh, it feels like that goes in there okay, actually. And that should, I mean, it worked before. Now we'll des test. Give that a second because it is dead test, and if it's a working system now, it needs a second to start up. But no, still not working. Can I get anything to work on this? Let's test mini. I'd need a tape deck attached. Back to the old faithful. Sorry, Matt. I don't think this machine likes your test. Right, so memory test after this a lot. I haven't got the test harness connected, but I know that that doesn't need connecting again. So I know that all the other chips are testing good so far. It could be hiding some faults. Same chips. Okay, so I think it's time to pop one of these chips out. I'm going to take out U12 first, and it did come up with the same range of chips that it thinks are faulty. So I'll take out U12 first, and then if that's faulty, then we'll take out all the others. It is likely, I'd say, in my opinion, it's likely that this shorting has taken out all of those chips as well. Because we don't know how it shorted. It could have shorted, I don't know which one it was now, but it could have shorted 5 volts to a data line or something. So it could have taken, well, we're lucky that nothing else went. Yeah, U12. Yeah, this one didn't, I don't think I got all of the solder this time, so I don't think I'm going to get away with just levering this one out. I think it's going to require a bit of heat. Just clip that resistor pack with the soldering iron. Oh, it's coming straight out. Okay, here is my... Phil's going to tell me off because I still haven't updated this. Version 5.28. Pretty sure there's a newer version. 4164. Oh, it's going to pass. It's not the memory. What could that be? Okay, things just got very interesting. You never know what a C64 repair is going to do, is going to be like. It could just be absolutely anything. So I approached this knowing that that chip, before I started recording, I knew that that chip, that 74LS257 in U25, was red hot. And it could have been just that chip, change that chip, end of the video. And now we are 3 chips in, 2 have been faulty, supposedly. And it's still broken. And what's really interesting is that the diagnostics is doing weird things. I need to check that cartridge port. Seems okay. Okay, so I've just spotted that the PLA, that socket has been changed. Now, the fault manifesting in the way it is points to the PLA. And I know that this is, oh, sorry, that's the SID socket. No, that is the PLA. And I know this is a good PLA. I think there might be some damage underneath there. I'm going to have to take that socket out and check it. Oh. Okay, there is, in that socket, under there, some solder mask across a couple of lines. And it looks, I've got a horrible feeling this is my work, that I've worked on this one before. I've got a feeling that that this was me. Okay, I think the next thing I can do, or I should do, is fire up the Classic Repair Toolbox software, and then I can actually check these traces or check these pins to where they're supposed to go, and that's going to make this super easy. Right, let me get that sorted. Right, okay, so I did find something. What I did was I went on to this amazing piece of software. This is up to version 2.2.0, and it's the Classic Repair Toolbox. I've shown this before, but it's worth repeating how good this is. And I'm looking at the Commodore 64 250-407 longboard. There is actually some more stuff in here as well. For instance, we've got an issue 4B ZX Spectrum, which has the full schematics available to it. This is going to be amazing. Yeah, so I'm very excited about that. I'm hoping that the issue 2 and issue 3 boards get added, and maybe some of the others as well, but I don't tend to fix too many 4Bs, but I'm looking forward to the day that I do now. But anyway, back to Commodore 64 250-407, and we're on the board view here, and because this is using the KiCad schematics, it's showing me all of the connections for everything. So what I did was I zoomed in on the PLA here, and one by one I would highlight a pin and then check. Once you've got the pin highlighted, I'll move the mouse off the screen, because if you're moving the mouse around the screen, everything just flashes. And then just check the continuity between those 2 points. And I went through every pin on here until I got to, let me just disconnect that one, until I got to this pin here, which is, says there, pin 10, which is the ROM H signal, ROM high signal. And between that point there and this point over here wasn't connected. And that goes off to the cartridge port. And that, it basically is one of the mechanisms that tells the computer what sort of diagnostic card, or what sort of ROM is being used here. So it's for the XROM and for these different modes here. And without that, this isn't not, well, a lot of this is not going to work. Some of it should still work, and I didn't try all of it. And it looks like the computer is basically working. Anyway, I've connected that up. I've made a quick bodge on the back with a piece of enameled wire. I'll tidy that up later, but I've just done it for now, just to connect those 2 points together to make sure that diagnostic cartridges will now work. And this is what happens when we use the Des Test max switch. So that wants to be on switch mode on bank 0. So we'll put that in. Now we get this. So it's not the cartridge's fault at all. Any cartridge that uses that line wouldn't have worked in this computer. And I've tried the other Des Test and other versions of Des Test, and they all work now. So that is flagging up on color RAM, and I get this wall of shame as well. Give that a reset. I want to watch. So it's an orange border says color RAM. Here we go, color RAM. And that is bit 2. Bit 2 has Matt Desmond will be crawling all over this screen because he understands what all of this means, probably, but I don't. So that red line there I know means bit 2, and that which is bit 2 is U22, is date line 2, and U22 on the schematics, which I think is that one there. So if I look at the data line there, that is connected to a lot of chips. Yeah, but before we get dragged into bit 2 and chasing that around the board, it also said color RAM, and I scoped all of the signals on the color RAM, all of the pins on the color RAM, and compared them to, if I click on this color RAM here, and we get this screen come up, and it will show me, it shows me the pin out, but it also shows me what the pins should look like as well. So this is pin 1, which looks okay. This is pin 2. So I'm hoping that they look the same, basically. This is pin 3. Yeah, that looks good to me. Pin 4. Yeah, that's acceptable. Pin 5. I think so. Pin 6. Yep. Pin 7. I think that looks okay. Pin 8 looks okay. Pin 9 is ground. Pin 10 is okay. Pin 11. Oh, not making good contact. Hang on. Oh, well, that doesn't look right. Let me just take the cartridge out, just in case that's influencing things here. Yeah, I think it was. Yeah, pin 11 is okay. Pin 12 is okay. Pin 13, it's okay. Pin 14, yeah, that's all right. Pin 15, it's all right. Pin 16, mostly okay, yeah. Pin 17, that looks all right. Pin 18. Yeah, I can't see anything wrong that makes me suspect the color RAM. But the next problem we've got is that data line 2 is connected to all of these different things. So we've got a couple of points on the cartridge connector, and we've got one on the VIC2 over here. We've got one on the SID, one on the PLA. I've removed the SID, by the way. One on the CPU, one on each of the ROMs, one on each of the CIAs, and U22, plus a couple of points down here. I don't think that's any, yeah, those 2 chips there are connected to it. So, okay, so what do I do next? I could just start pulling out any chip that's associated with that one, and I can show you what that looks like, data line 2, on the scope. That is on U22, On U23, this is a good data signal. We get back. That's a good data signal. That's a healthier looking one. And this is the bad one. Now, with it being connected to everything, you've got to look at what's the most likely thing to have failed, coupled with what is easiest to test. So we've got a couple of options here. One is this 4066 down here. So they often go wrong, but this isn't a Moss branded one, so I'm not liking that as an option. U22 as a RAM is a good option, especially seeing as this failed and it's on the same bank. Whether it would be taking all of the other memory with it in diagnostics, I don't know. The CIAs are always a good option, and the ROMs are as well, but because it's such a small chip, and for one other reason as well, I want to show you here, U22 is just, and this is something you probably wouldn't be able to recognize by using your finger or isopropyl alcohol, it's just a little bit warmer than the chips next to it. So the chip next to it is 39.2, the one over from that 38.3, but this one is 40.9 or 41 degrees. So just a couple of degrees warmer than the ones next to it. That could just be that it's working harder because that data line is being stressed more. I don't know, but I'm going to take that one out and test it before I go any further. The next thing is to, oh actually no, I'm not. I'm going to take this VIC2 out, which is really hot. Yeah, that is really hot. I'm going to take that VIC2 out and do I test it in another board? I probably should. Yeah, let's test that in another board. Okay, here's my test machine. Actually, verify it's working. Sometimes I leave chips in here that shouldn't be in here. Always takes longer to start up than I like. I'm going to use same test, des test switch, just to go past that color RAM test. Yep. Let's pop this out. That's not very promising. Quite a grotty looking socket. I think it's single wipe still. I need to change that. That's better. Okay, this is the test and that's passed. So that is okay. I think that probably rules out the VIC2, but I'm gonna, this one got really hot, so I'm gonna use my R3 in the test machine, in the faulty machine for now. Right, same problem. Slightly less hot chip. Let's get U22 out. I'm still not sure why 5 chips would have been, coming up on the diagnosis on the diag cart as faulty. Right, let's give it a little wiggle. Looks like all the solder's been removed. Yep, got lucky every time so far. Okay, Is it gonna pass? I think it will. Yeah, there's something else. Something else on the data bus is causing this to go bad. So I'm going to attempt to desolder each pin. What's encouraging me to do this? This is the happy little diodes Jim method of isolating an address or a data line by desoldering the pin and moving it in the hole so that it actually isn't touching anything. I've got tools to do this. I've got these are desoldering pin things. I've got to find out which one of these fits over the legs of this chip. Not that one, that's for sure. And in the holes, not that one. So maybe that yellow one. Yeah, perfect. So it fits over the legs of the chip, and it fits in the holes of the on the board. I'm going to stuff this straight back in here. I'm not going to put it in a socket. It's a good chip. There's no reason to put it in a socket. That's just making work for myself. None of these chips are going to go faulty. None of them are faulty, even though I've removed two of them. One of them I've put back in the socket and the other one I'm not. This is just how I want to do it. Right, so looking at the schematic, I've got to focus in on, what is that? That's pin 31 of the CIAs, pin 11 of all of the ROMs. I think my next best target is actually the CPU though. Wonder where the signal is generated. I need to know that. I just looked it up, and from what my minimal research shows me is that the data lines are driven from everywhere. So there's no one chip that actually says, you know, the responsibility is handed off to multiple chips, all of these ones that are connected. So, okay, I've just realized I wasn't recording for the last bit, in which I disconnected the pins for all three of the ROMs, the pin 11, disconnected them from the data line by using a little desoldering tool. And the CPU I disconnected as well, and that's all I've done so far, those four. And now I'm just about to remove U16. I tried to disconnect its pin on its own, but it wouldn't play ball. So I'm just going to pop this one out, and I just desoldered the wrong side of, right, so I desoldered the wrong side of that chip, or the wrong set of legs, and I've put that right and desoldered the right side. Let's see if it comes out now. It's getting really hot in here, so I'm getting quite crabby. Okay, this was meant to be an easy fix. It might still, I don't know if that's actually going to do anything. Does it run? Yeah, oh yeah. Oh, that's to do with the color RAM. That's interesting. That's controlling something to do with the color RAM, which came up as a potential problem on one of the diagnostics. So do we have a good data 2 line now? No, I don't think we do. I'm going to put a socket in there anyway and change that chip for a known good one, just to see if that makes a difference, because I'm not sure if what I'm seeing on the scope without that socket or the chip in there is accurate. I've just remembered this might be a board that I worked on in a live stream and then said I'll come back to when it didn't finish. Right, if it isn't this, then we're running out of options of what it could be. I've tested the VIC-2 in another machine, and this is a different VIC-2. The SID is not present, that one. The PLA is probably worth changing for another one, but it is one that's I can grab one out of my working board. CPU, we've checked that data line. We checked the data lines on all of the ROMs and this chip, the DRAM down here, and now this 4066. It's only the CIAs left, which were on diagnostics behaving themselves. So I don't know. First thing I want to do is get a different 4066 in here. 4066. It's just I'm encouraged because the coloram error earlier was linked to this. So let's see what Des Test Switch makes of it now. If it gets past that orange coloram test. Here we go. No. Still bad. All right, we're down to the CIAs now, which is pin 31 of both CIAs. I'll try to get the pins desoldered, but I'm not sure if it's going to work. 9, 8, 7, 6, 5, 4, 3, 2, 1. Here it comes up. Wow. Not sure what happened there. Well, they look pretty good. Before I go poking at them with anything, let's see if they're actually disconnected. That one is. All right, so one of them is. U2 is disconnected, so let's try that one. Let's try that now. Does it fire up? It does. It's gone crazy. Okay. What on earth is going on? It is still not up at 5 volts. Okay, it must be U1. Surely it's U1. Does it change? No. Makes no difference. I'm confused. There must be a pull-up resistor somewhere that's not working. Where are they? Okay, there's no pull-ups on the data lines. Not sure what I was thinking there, but that's address lines have pull-ups. The data lines rely on the each chip to pull the signal to 5 volts. What's happening here is something is pulling it back down or not allowing it to get to 5 volts, and I don't know what it is. The only one I haven't completely ruled out is the CIA in U1, so I just need to make sure that that is desoldered properly, that pin. What is this going on here? Okay, now it is. Let's turn it on, and once more scope U22's pin 2, and it's still only 3 point something volts. All right, let's get another PLA in there just in case it's that. And I've been around this board for no reason. It could be that this PLA has just failed. Well, this is not a MOS one, so a slightly better quality one. What do we get now? Still the same. I don't think I'm looking at the solder on U22. Did I remove that? It doesn't, it looks like I removed the one next to it. Yeah. I did. Removed the wrong chip right at the start. Oh my God. Look, it's really hot in here. Well, it wasn't the worst exercise in educating myself about how these things work, and a good use of the Classic Repair Toolbox as well to chase the signal around the board, but I should really have got this right quite early on. Right. Oh, it's going to pass, isn't it? It's passed. What the hell? Oh, we've got 5 volts now. I mean, it looks horrible. No, it's working. That chip is bad. That chip is bad. That's a false positive. This is one of the weaknesses of modern testers, is that they might not pick up something that's marginal on its voltage levels. I wonder if this needs some settings changed. Pre-tests. Oh, high Z leakage is off. Ah, sorry, Phil. Okay, so high Z leakage is off. Data line pin 14 stuck low. Interesting. I wonder if any of the others, maybe that one I put back in is also faulty. Let's get a socket in there. I've put the socket in, and here's a chip that I've tested that passed. And now what happens? Does it still boot for a start? Right, still boots. What do we get on data line 2 now? Now we get a lovely signal. Nice working machine. Right, let's turn that off. Now with there's test max switch. Does it pass that color ram stage? Right, here we go. Yes. Right, I'm going to let it run through the whole of the diagnostics for Des Test Max. No, Des Test Switch. And then I'll connect up the test harness. Oh, my solder was quite close to the board then. I'll connect up the test harness and give this a proper test. Okay, so it's passed all of the other tests through Des Test Switch, and that's a really good stress test for the memory, and probably the best way to test the memory in the board is where it's going to be working. But just as an illustration, so this failed on the data bit high, stuck low. The data pin 14 stuck low. So I'll just show you it again. Start. Yep, same error. And if I put this in my old 1-bit tester, It passes. That would have sent me round the bend finding that fault before if I'd have been relying on this tester. Okay, so what have we got left to do? Connect up the test harness again. Stick a SID chip in it. That's not a SID chip. There's a SID chip. I'm pretty sure it's going to pass everything on this test because it already did. Even with the bad memory chip. But it would be daft not to just to go through it one more time, just to make sure everything is still, it wasn't masking any errors or anything crazy like that. You should be getting sound now. It's possible that some of the sound was missing because I'm not sure that's a fully functional chip. I just want to try it on the RAM test as well, just to make sure that passes as well. So yeah, this, I'm pretty sure I remember this was a live stream. I think it was the live stream where we did the charity thing for the Steam Card Pro raffle. So if you want to see the very start of this repair, you can, I will leave a link to that video in the description and with a timestamp to that part of the video. And I'm pretty sure what happened was we found that the PLA and the SID were faulty. Oh, I do need to change that VIC2 out. And that there was some damage around the socket for the PLA. Somebody had done some work on this previously. So I repaired that on stream, but I must have missed one. Well, I don't think I had access to the, did I have the Classic Repair Toolbox? I'm not sure I did. But, oh look, that's all passed once. It's done a loop. That's good. But yeah, that's where I started this journey, and I put it to one side thinking, oh, I couldn't fix that on that stream because I probably ran out of time. So I moved on and forgot about it. I've got such a bad memory. Right, let's get all of this out. I've got one thing to test, one last thing before this is a complete working, highly abused machine. Got good clips on this one, nice case as well. That cartridge can come out and this one can go in, which has got Matt Desmond's keyboard test, which I very much like. Okay. It's not the easiest keyboard to press, this one, for some reason. Excellent. Clean bill of health. I can button this up after I put all the screws back in and put it away. Marvellous. So what was wrong in the end? Initially the PLA and the SID, some broken traces under there, another broken trace that was connecting a pin over here to the cartridge port for the ROM high signal. Everything else is functional. That chip was okay, that one was faulty. So that DRAM U22 was the one that led me to a merry chase. This one was melting down, and this one was also, I think, faulty. Yes, it was faulty. So both of the multiplexers went wrong. And the VIC2 is very toasty, so I'm just gonna have to find a can for this one. I've got plenty of spares of those. Find a can and thermal compound it and tuck it up. Tuck it in, tuck it up. I don't know. It's so hot. Right, okay. Yeah, that's that for this one. I can happily walk away saying I almost did a good job. Right, for those that are inevitably going to tell me off or say that they were screaming at the screen all the way through the video. That's fine. I could have edited that out. I could have edited right from the point where I diagnosed U22 was the problem, then took the wrong chip out. I could have just ignored all of that next half an hour of the video and you would have had much less entertainment. So I'm hoping that you're grateful that I do include my mistakes, because I always find that they're the best way to learn. Right, I'll see you at Retrofest. Goodbye. I'm definitely not an idiot.